right, guys, here we go. Sorry, I didn't get this up there yesterday. It's this first week for teachers is kind of like, for me specifically, it's kind of like you guys at finals week. I got everything going on at once, and I don't have a pattern going. So we reverse roles in 3 months. You guys have all sorts of crazy stuff going on, and I don't have as much. So let's talk about even and odd functions. So what we mean by this is the idea, and you guys, let's see, the idea that one is symmetrical across the y-axis, and then the other is symmetrical across the origin. So let me show you what I'm talking about here. So the basic even function is y equals x squared, or as we write it, f of x equals x squared. Sorry for the writing. So that's a parabola. So if I draw a parabola out like this, and that is horrible. The idea, besides my horrible drawing, is that the left side is the same equidistance as the right side. So there's a way to prove this. So in other words, if I put 2 in here, I get 2 and 2, let's say. That means if I put in -2 on this side, I'm going to get 2 on this side. So if you guys can see that, when I put a negative x in, I get out y. And when I put a positive x in, I get out y. Notice how y's are the exact same. So y1 equals y2. That's the idea of an even function. So we take it farther into a proof. So let's go to a proof. And this is what you guys are going to need to know right now. The proof, which those are on page 16 of your book, just so you guys know, page 16. The proof is this, that if I have a function, f of x, right? If I have a function, f of x, and then I plug in f of negative x, and I get x back out, then it is even. So let me show you. So we're going to take this. Is x squared even? That's what we're talking about. So I take this, f, I plug in negative x. What did we talk about the other day? That if I plug in negative x here, I have to plug in negative x here. And so what happens is this. If I plug in a negative x, then I get out positive x, because you guys see how that works? So now I've got a positive version of this. That's the idea behind it. Okay. So basically, the idea means that if I plug in a negative number, I get the function or a positive function back out, is the idea behind it. So let's look at our basic uh, odd function. So odd functions look like this. And the easiest way to show it is this is y equals x cubed. Okay, notice that this is even and it's an even function. Notice that this is an odd and it's an odd function. Those are base ones. It's a good indication, but it's not necessarily true that it's going to be an odd. But like an odd function usually won't prove to be an even one. So let's prove that this is odd. For it to be odd, I need this. For it to be odd, let me go back to red. For it to be, I got to go back to red. For it to be odd, I have to be able to plug in a negative x, and what I get out is the negative function of x. In fact, I'm going to rewrite this. I like this better. If I plug in negative x, I get f of x back out. Okay? That makes more sense, because if f of x is x squared, what did I get back out? X squared. So I like that better. So for this one, if I plug in negative x, I'm going to get the negative function back out. So let's look at this. So what do I mean? So I'm going to take f of x, I'm going to plug a negative into it, and I'm going to take negative x and I'm going to cube it. And so when I cube negative x, I get negative x cubed. Look at my function right here matches, okay? And that's the function I started with, but its entire value is negative. So therefore, three dots is therefore, it is odd. It is odd. I am having trouble this morning, guys, right? Okay. We'll go over a few of these because these kind of can get confusing. What does it mean when given only the x value? I'm trying to think of even why I asked you guys that question. It's going to pop up on the worksheet, I guarantee it. Let me think about that one. I'll come back to that one. I'm not sure. I'm not sure what I'm looking for right there. I wrote these the other day and then I meant to do them and I didn't. So, what does it mean? I'm going to go back to that one. What does it mean when given only the x value? Don't know. We'll come back to it. All right, so domain and range. Just remember that domain is, the way I look at it, is your usable x values. So in other words, if I take this graph here and I draw the graph that goes like this, right? These x values over here, we don't use. So how do we state it? There's a couple of ways to state it. We can say x is greater than or equal to 0 because I put a solid dot here. If it was an open dot, I would say, if that was an open dot, I would say x is greater than 0. Okay, so that's for a solid dot. That is for an open dot. And then there's other ways to write it where we could say for the solid or inequality like this, where it's greater than or equal to, we could say interval notation from 0 to infinity. Okay, and infinity always gets that piece. My computer's going to die here soon. Let's get through this one. All right, and then if it was an open dot, it would be from 0 to infinity. Or you might see stuff. This one can be written like this. It's a numerical set. X such that x is all numbers greater than 0. Kind of crazy, isn't it? All right, so this just means x such that x is a set of all numbers greater than 0. It's just kind of one of those weird ways to write it. And so range, same idea, but range would be, let's do something a little different for range. Let's do something like, let's do a parabola like that, ugly parabola, and it's at negative, it's at 1 and -2. Okay, so if it's at 1 and -2, range would be all real numbers. I'm sorry, domain, because domain is all usable x values, and I can plug in any x value I want. So my domain would be all real numbers. So I'm going to go from negative infinity and to positive infinity. So I'm going to go all across this x-axis is what I can use for domain. But let's talk about the range. The range is a little different. The range is our y values. So we're going to be y such that y is what? Y is less than -2. And then We have, again, multiple ways you may see this written. It may just be y is less than or equal to -2. Or it could be interval notation where y is going to be, I've got I got a less than or equal to, so it's a bracket to -2, and it's going all the way down to negative infinity, and we got negative infinity. Okay, it's not an 8, that's negative infinity. And I'm still struggling. What happens if they just give you an x value? I'm really not sure. Let me look at something real quick, guys. You guys might be able to see that. Let's look at, oh, maybe not. Maybe it won't be real quick. I want to look at, I probably looked at your, oh, I got you. I got you. Now I know. See, I knew I'd figure it out for you guys. Let's go back to, nope, wrong thing. Cami right here. All right. So what does it mean if they just give you an x value? They're going to tell you something like this. It's an even function, and they say that if it's an even function and the first thing I put in is -8, oops, I was going to draw an infinity. I put in -8, but I get out equals 4. So when I put in x, I get 4 out. Well, if it's even, we know it's symmetrical on both sides. That means if I put in 8, what am I going to get out on this side? Well, I should get out the same number, which is 4. Okay. So that's the idea of what if they only give you an x value. So they're trying to relate the fact that even functions are symmetrical. So whatever I put in here for an x value, I get the same a y value. And if I move over here and plug in this the opposite x value, so like I said here, it's -8. If I plug in 8, I'm going to get the same y value out. That's the idea. So if it's an odd function and we look at it and we say, oh, when I plug in 2, I get out 3. That means when I go to the other side of the function and I say, if I plug in -2, what am I going to get out? Well, I'm going to get out -3 because it's going to go through like this, and I'm going to be able to get 2, -2, and 3, and this side's going to be 2 and 3. That's the basic definition. That's what they mean by if you only get an x value. So we are done for that one. Again, sorry it wasn't posted. We have some review coming up and some different things. So if I could actually turn this thing off, it'd be great. There we go.